So at this point, I'd like to provide you with a demonstration of a performance case study using Perfmon and the Windows Performance Toolkit. Before we dive into the demo, I'll give you some details about the case to get your bearing. So the problem affected about a dozen different servers running 2008 R2 SP1 that would experience network outages. The problem would take several days to a week before it starts to occur, making it very tricky to troubleshoot. Now a reboot would actually clear the problem. The interesting thing to note is that Perfmon data collections would have gaps at regular intervals when no data was recorded in the log files. Now these gaps corresponded to times when the network events would occur. To give you an idea of what sort of events were occurring, we could see here they were primarily cluster node unreachable, like an event 1126, telling us that the cluster network interface is unreachable by at least one other node in the cluster. We would also see various event 1129s telling us that the cluster network was partitioned and that some attached failover cluster nodes couldn't communicate with each other over the network. So with these type of events that we're seeing, one would think that the network drivers involved would be at fault. So at this point, we made sure that all the various network drivers were indeed updated to the latest revision. Unfortunately, the problem still occurred. So let's go ahead and dive into the actual demonstration of this case study. Okay, here we are. Just going to give you some background here. I'm going to pull up the command prompt and just go ahead and type out the collect-perfmon.txt file to give you an idea of the commands that were used. So here you could see the logman create counter. We reviewed this in the slides, and I can actually issue this command right now. And if I were to issue the logman command by itself, you would see there is myperf, the data collector set out there, in a stopped status. I can then get more information about it by doing the logman query command, giving it the name of the data collector set. And as you can see, quite a bit of information goes scrolling by, so let me just get back here. You can see the name of the data collector set, things like how large the file is allowed to grow, how often we're collecting samples, and all the various counters that we're collecting data on. So then we can turn around and do the logman start myperf to actually start it running. As you can see, the command completed successfully, and I can just use the logman command by itself, and you can now see that the status is indeed running. At this point, once we collect the data we need, we can do the logman stop, giving it the name of the data collector set, and we can see the corresponding data that it collected in the c:\perflogs folder. And here is the perfmon log file that it just collected. That is what you would read into Perfmon to get your analysis going. Now, as I mentioned, we collected the data in Perfmon, and you could see these gaps in the output on the chart there where no data was collected at all. And that's very odd for Perfmon not to be collecting data. So let me explain, give you a little background. If Perfmon can't collect data at the time for whatever reason, it will just not record anything. So there's something going on during those gaps of time period that's preventing Perfmon from collecting data. So let's go ahead and look a bit deeper. So as I mentioned, we can take a look at the xperf collection file, collect xperf.txt, and that'll give us information such as the long command line that one would use to start an xperf collection. Now you can go ahead and issue that command, which I'm doing right here, and then I can use the logman command once again, -ets, that's event trace sessions, to see which ones are out there. And there's a variety of them out there running already, and the one we just started is called nt kernel logger. So we can then eventually stop that data collection by doing the command xperf-stop and then give it a name of a file. And it takes a few moments because it's trying to record everything it's been buffering in memory to this output file. And once the command completes, you can see the resulting ETL log file. And as you can see in this case, it was 84 meg that we just captured. So that's how you go about starting and stopping an xperf command. So now that we've captured the data for the xperf trace, we can go ahead and bring up the Windows Performance Analyzer. As you can see, it's got these thumbnail charts on the left-hand side, which may give you an indication as to where the activity of concern is. Now, we could take a look at something like the computation. Now, it had a triangle next to it, so I expanded that triangle, and you can see several more sub-graphs or sub-thumbnails. And the one we're interested in is this DPC ISR. If we were to double-click this, it would essentially bring this chart into the larger analysis pane so we can take a more detailed look at it. And as you can see, there's spikes right here when the IOs are experiencing very lengthy delays. And these spikes coincided with when those events that we looked at were logged. So by doing the correlations here, we can see that store port, because I'm just highlighting the graph over these peaks, and it's store port that's executing at the time. If I were to go over to this peak, once again, it is store port. So at this point, we would want to make sure that all our storage-related device drivers were up to date, such as storeport.sys. Unfortunately, even after doing so, the problem still presented itself. So at this point, we might want to drill down a little bit more. What I'm going to do is just display the graph only. And now I'm going to go over here and look at a bit more data from a thumbnail. I'm going to click on the CPU usage sampled, and that will reveal a number of additional subgraphs. So I'm going to scroll down. I'm going to find utilization by process and thread. So I'll go ahead and double click this and bring it into the viewer in the analysis pane. And so we can see that where these peaks were, there's also activity below here. So what we can do is actually filter down to just the system threads. These are the threads that are running obviously in kernel mode. So I can right click it and say filter to selection. And that's going to provide me with just those modules that are running in the kernel context. So we can do a few more things here by adding the module column. So I'm going to right click the headers and add the module. So this allows me to reveal this module right here, the name that contains the functions. And we can then expand this triangle here and show just those modules that we're executing at the time. One of them happens to coincide exactly with where these peaks are occurring. So where storeport was experiencing these lengthy delays, there's another driver out there that starts up at the exact same time. And in doing so, this driver was essentially preventing Perfmon from writing out its data records. So we can quickly focus in on this device driver as the culprit that was causing the lengthy I/O delays for the storeport driver. So you can see that this particular driver started up each time storeport experienced a delay. So it was in fact this dktlf.smf.sys driver that was causing the problem. By upgrading this driver, the problem in fact went away. So hopefully this gives you a good idea of how to go about utilizing both Perfmon and then taking it to the next level by utilizing the Windows Performance Recorder, or in this case xperf, to reveal those kernel mode metrics.